Okay, for question 5, it wants us to evaluate absolute value expressions, right? Okay, so remember absolute value. Let's just do a quick refresher. If I take the absolute value of a positive number like 9, right? The absolute value of that is 9, right? The positive value. If I take the absolute value of a negative number, the value of that is 9. And the reason for this, right, is because the absolute value, right, is the distance from that number, from whatever's in here, to 0 on the number line. So if I had negative 9, right, 1, 2, 3, 4, 5, 6, 7, 8, 9, the distance from negative 9 all the way to 0 would be, if I counted 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So the distance is 9, right? Distance is never negative. So clearly we're not going to count on the number line every time we have an absolute value. We're just merely going to take the positive value of whatever number is under the absolute value. So let's do these. So for A, right, I have the absolute value of 54, and that is just 54, right, the positive value. For B, I have a negative, and then I have negative 7 3/5. So we have to do this one at a time. Absolute value symbols are like parentheses. They're grouping symbols. We need to do what's inside first. So I do the absolute value of negative 7 3/5, which is 7 3/5. But don't forget, I still have this negative out there. So this one becomes negative 7 3/5. For C, we have the absolute value of 3, which is 3, minus the absolute value of negative 1, which is 1, and 3 minus 1 is 2. And for the last one, D, right, we have the absolute value of 2.2 minus 5.13. So if you can't do that in your head, you're going to have to come over to the side, right, and say 5.13 minus 2.20, right, 2.2, and subtract, right? So 3 minus 0 is 3. I can't subtract 2, so I need to borrow 1. So 11 minus 2 is 9, and 4 minus 2 is 2. But this was 2.2 minus 5.13, so it's negative 2.93. So what I really have is negative 2.93 in there. So the absolute value of that is just positive 2.93.